morning, everyone. You are watching Guru Brahma classes for JEE and NEET. In this session, we are going to discuss Gibbs energy from the chapter thermodynamics. We are speaking about PYQ in this session from the Gibbs energy, right? In 2015, this question is given. What is the question given? Let us see. The following reaction is performed at 298 Kelvin. So what is that reaction? The reaction given is 2NO plus O2 gives rise to 2NO2 G. All these three are gases. Okay. The standard free energy of the formation of NO. How do we represent standard free energy of the formation? We represent delta GF naught. Okay. So what is given for NO? It is given for NO. It is given as 86.6 kilojoule per mole. Right. What is the standard free energy of the formation of NO2? What is asked? Delta G naught F of NO2 is asked. How much? So Kb is given. Kb is given as 1.6 into 10 power 12. Okay. We know that delta G naught, we have a formula. We have derived a formula. What is that formula? Delta G naught is equal to minus RT natural log K equilibrium. Here K equilibrium can be Kp or Kc, right? K equilibrium can be Kp or Kc, right? So equilibrium constant, this can be Kc, K, we can write K equilibrium, which is equal to Kp or Kc, right? So we have a formula delta G naught is equal to minus RT log K. Here equilibrium actually, what is this? Equilibrium. Here equilibrium constant is given as pressure equilibrium constant. So I can write it as minus RT natural log Kp. So delta G naught. So we want delta G naught. But here for a reaction it is given. What is that? Reaction. For a reaction we have a formula to calculate delta G naught of the reaction. Delta G naught of the reaction is equal to sum of the delta G naught of formation of products, P means products, minus sum of the delta G naught formation of reactants. Okay. Here summary means if there are more than one reactants and if there are more than one products, you have to add them. That is the symbol sum, right? So you can write delta G naught of the reaction is equal to products. What is product here? You can write delta G 2 into, so 2 moles are there now, 2 into delta G naught of formation of NO2 minus, okay, there are 2 reactants, so 2 into delta G naught of formation of NO plus delta G naught of formation of O2, right? Now you write delta G naught of the reaction is equal to 2 into NO2. For NO2, how much it is given? We want to calculate. that. So delta G naught of formation of NO2 we need to calculate minus 2 into how much delta G naught of formation of NO is given as 86.6 kilojoule. 86.6 kilojoule per mole plus, see, delta G naught of formation of elements in their standard state is equal to 0. So what is that condition? Delta G naught of formation of the elements, delta G naught of formation, enthalpy, standard free energy of formation of elements. What is this? Delta G naught F means what? The standard free energy of the formation. Standard free energy of the formation of elements in their standard state. Is equal to 0. So that is the reason why element here, you see, oxygen is element. Oxygen is a element, whereas NO2 and NO are compounds, right? So for this element, and this is present in the gaseous state, standard state. Oxygen is present in gaseous state at room temperature, and that is taken as standard state. In their standard state, say enthalpy of formation, standard enthalpy of formation of the elements is taken as a 0. So for oxygen, we have taken it as a 0. So then what do you get? Delta G naught of the reaction is equal to 2 into delta G naught of the formation of NO2 minus, right, 2 into 86,600 joules you can write, because it is given in kilojoule, right? So we have delta G naught. Here delta G naught means delta G naught of the reaction. You can substitute here, right? So here let us take from that equation, delta G naught of the reaction is equal to minus RT natural log Kb. So what did we get there? 2 into delta G naught of formation of NO2 minus 2 into 86,600 joules is equal to minus RT natural log Kb. Right? If this 2 into 86,600 goes that side, it becomes plus. So what you can write? 2 into delta G naught F NO2 is equal to, what you write? 2 into 86,600 minus, right, R into T. T how much given? You see, at temperature in the question it is given as 298 Kelvin. How much given? 298 Kelvin. So R into 298 into log, natural log, how much Kp is given? Kp is given as 1.6 into 10 power 12. 1.6 into 10 power 12 is given. Then I want only delta G naught F NO2. If this 2 comes this side, it becomes 1 by 2. 1 by 2 means 0.5. So 0.5 into 2 into 86,600, okay, minus R into 298 into log 1.6 into 10 power 12. Okay. So where is that answer? You can find that answer here, right? Which option you are finding? 0.5 into 2 into 86,600 minus R into 298 natural log 1.6 into 10 power 12. So this is the answer. 4th. So what is asked? Delta G naught F of NO2, that is standard Gibbs energy, standard free energy of formation of NO2 is asked, that we have calculated. Okay, so let us go with the next question. So let us see that question which is given is 2019. In 2019 the question is given. So what is that question? Let us see. What he has asked, a process has delta H is equal to 200 joule per mole and delta S is equal to 40 joule per Kelvin per mole. So delta H and delta S are given. Out of these values given below, choose the minimum, this is important, minimum temperature above which the reaction will be spontaneous. So the overall factor responsible for spontaneity of a reaction, overall factor responsible for spontaneous process. What is that? Delta G. Where this delta G includes both factors which are responsible for spontaneity of a process. What are those two factors? Delta H and delta S. So delta H is enthalpy change, delta S is entropy change. These delta H and delta S both are responsible for spontaneity of a process. For a process to be spontaneous, these two factors. So which involves these two factors? Delta G. So we say that delta G is the overall factor responsible for the process to be spontaneous. Okay. And we have studied that for a process at equilibrium, we have studied that delta G is equal to 0. For a process to be spontaneous, delta G is negative. For a process to be non-spontaneous, delta G is positive. So these things we have studied. So first of all, let us see at what temperature the reaction is becoming equilibrium. To solve such type of question, we have to see this. So let us see delta G is equal to 0 for equilibrium. At equilibrium, we say that 0 is equal to, because delta G is 0 at equilibrium, delta H minus T delta S. Now we can write delta H is equal to T delta S. T is equal to delta H by delta S. Right? Let us solve here. So what is that? T is equal to delta H by delta S. That is equal to. So delta H how much given? 200 joule per mole by delta S is equal to 40 joule per Kelvin per mole. Mole, joule. So for 5, right? So temperature is equal to 5 Kelvin. So this is the temperature at which the process is in equilibrium. So let us substitute in the equation delta G is equal to delta H minus T delta S, right? So that is equal to delta H how much given? 200 minus T how much you have calculated? 5 into delta S 40. So then it becomes 0. 200 minus 5 into 40. This is 0. So if you increase the temperature above 5, let us see that 200 minus, if I increase the temperature up to 6 Kelvin, let us take 6 Kelvin, then what you get? 200 minus, how much you are getting? 6 4 20, 240. That means minus 40 you are getting delta G. Here delta G is equal to minus 40. What does minus represent? Minus represent that the process is spontaneous. If the temperature is increased more than 5 Kelvin, then delta G becomes negative. If delta G becomes negative, the reaction will be spontaneous. So that is what the question is. Choose the minimum temperature. This 5 Kelvin is the temperature at which the reaction is at equilibrium. The process is at equilibrium. If you increase more than 5 Kelvin, what happens? The reaction is becoming spontaneous, because delta G becomes negative. If delta G becomes negative, we have studied that the process becomes spontaneous. So above 5 Kelvin, that is the minimum, least temperature above which the process becomes spontaneous. Okay. Next, let us go with this process. Question number 4, which is asked in 2019. What is the question? The standard reaction Gibbs energy for a chemical reaction at an absolute temperature T is given by, what is given? Delta G naught is equal to A minus BT. A minus BT. Where A and B are non-zero constants. So A and B are non-zero. Anyway, capital T will be greater than 0. Which of the following is true about this reaction? Okay. So we know a formula, delta G naught is equal to delta H naught minus T delta S naught. Okay. So this is very much similar to that of this equation. The given representation is very much similar to that of this delta G naught is equal to delta H naught minus T delta S naught. So then what will be A here? A will be delta H naught or delta H, standard change in the enthalpy. What will be B then? B will be delta S naught. That means standard change in the entropy. So whether a reaction is endothermic or whether a reaction is exothermic, who will decide it? Delta H will decide it. Okay. So for endothermic reaction, generally delta H will be positive. For exothermic reaction, delta H is negative. Okay. So we here in the first option it is spoken about B. What is B? Delta S. Delta S does not say whether a reaction is exothermic or endothermic. Who says whether a reaction is exothermic or endothermic? Delta H says. Okay. So first option is not correct. And second option, if it is exothermic, if A is greater than 0, A is greater than 0. If delta H is greater than 0, means delta H is positive. If it is positive, it should be what? Endothermic. What is that? It should be endothermic. But here it is given exothermic. So this is also not the correct answer. Endothermic if A is less than 0. So delta H is less than 0. Less than 0 means delta H is negative. What is that? Negative. Negative means exothermic. What is that? Exothermic. But here it is given as endothermic. So this is also not correct. A greater than 0. A greater than 0. Delta H greater than 0. That means delta H positive. It is endothermic. So endothermic if A is greater than 0. So what will be the answer? The fourth option will be the answer. Okay. Understood. Right. Next question. A process will be spontaneous at all temperatures. This is very important, at all temperatures. So let us see those 4 options. We know the formula. What formula do we know? Delta G is equal to delta H minus T delta S. Okay. And we know that if delta G is equal to 0, the reaction is at equilibrium, right? Delta G is equal to negative, it will be spontaneous. The process will be spontaneous. Delta G is equal to positive, it will be what? Non-spontaneous. So we are speaking about this will be spontaneous at all temperatures. So let us see first condition. Delta H is greater than 0. Let us go with one example. What is that? With one example. So delta H I am taking as greater than 0 now, plus 5 minus. For example, I have taken delta H greater than 0. So plus 5 I have taken. And delta S less than 0. Delta S less than 0. T I am taking as 1, for example, into less than 0 means minus 5 I am mentioning. Okay. Then what do we get? Plus 5 minus of minus again plus 5, right? In this way. At all temperatures he is mentioning. What is that? At all temperatures. So you are mentioning 1 here. Let us go with some 2. That is plus 5, 2 into minus 5. So plus 5 minus of minus into minus again plus. So 2 into, here what do we get? 5 2s 10, right? Minus of minus 10, that is equal to plus 5 plus 10. So always here we may be getting 0, for example. This is a condition. Here what you are getting? Plus. So delta G is plus. If you go on increasing temperature or decrease the temperature, overall delta G will be positive. Will be positive. Right? Let us go with one more. Decrease the temperature. Let us decrease the temperature. Already it is 1, 2 I have taken. Right? Or we shall increase one more Kelvin. So plus 5, 3 into minus 5. So what do you get? Plus 5 plus 15. So what do you get? Again positive. So here first condition will not be applicable at all temperatures. If you go on increasing the temperature or if you go on decreasing the temperature, what happens? Delta G will be positive. If delta G is positive, then it will be what? Non-spontaneous. Asked is the spontaneous. Okay. So this will not be the correct answer. So let us go with the second option. So delta G is equal to delta H minus T delta S. Delta H I am taking it as, for example, what is asked? Less than 0. Minus 5 minus of delta S greater than 0. 1 into something like plus 4 I am taking. So minus 5 minus 4, that is equal to minus 9. Okay. Or decrease or increase the temperature. Increase the temperature. Minus 5 minus of, right? 10 degrees centigrade I am increasing into plus 4, that is equal to minus 5. 10 into 4, 40, minus 40, again you are getting minus 45. So delta G will be always what? Delta G is always negative. Whether you increase the temperature or whether you decrease the temperature in this condition, as delta H is negative, as delta S is positive, always minus minus, you are adding minus and minus. If you add these two minus, you will get overall minus. Okay, so whatever the temperature it is, delta G is always negative. When the delta G is always negative, then it will be what reaction, what process? Spontaneous process. Okay, so this can be the correct answer. Let us go with the third option. So delta G is equal to delta H minus T delta S, right? That is equal to delta H greater than 0. Let us take it as plus 5. Delta S is also greater than 0. Greater than 0. 1 into plus 4, let us take. So plus 5 minus 4, that is equal to plus 1. So delta G is plus 1. What is that? Non-spontaneous. Non-spontaneous. But if you increase the temperature, let us increase the temperature. So plus 5 minus 10 into plus 4. I am increasing the temperature. Then what do I get? Plus 5 minus 40. That is equal to minus 35. So delta G is negative. How much you are getting? Negative. So negative means it is spontaneous. So that means at lower temperature, what is that? At low temperature, it is non-spontaneous, but at a high temperature, at low temperature, it is non-spontaneous, but at high temperature, it is spontaneous. But it is spontaneous. So condition at all temperatures, the condition asked is here at all temperatures, but at all temperatures it is not spontaneous. Let us go with the fourth option, and delta H is equal to delta G is equal to delta H minus T delta S, right? So delta H and delta T conditions what are given? Less than 0, both are less than 0. So minus 5 minus of 1 into minus 4, let us take. Minus 5 minus into minus plus 4, that is equal to minus 1. So delta G. So what is that? Spontaneous. But if you increase the temperature, let us increase the temperature. Delta G is equal to minus 5 minus of 10 into minus 4. That is equal to minus 5 plus 40. That is equal to plus 35. So delta G, how much it has become? It has become plus 35. That means non-spontaneous. So non-spontaneous at a high temperature, but it is spontaneous at a low temperature. So depending upon the temperature, the spontaneity is changing. Depending upon the temperature, the spontaneity of a reaction is changing. So at all temperatures, the reaction is spontaneous for this condition, second condition. So second option will be the correct answer. Okay. Let us go with the next question, question number 6. So the incorrect match in the following is, we have derived a formula, already we have discussed that also. What is the relation? Delta G naught is equal to minus RT natural log K equilibrium. So here K means K equilibrium actually. We can write it as minus RT natural log K delta G naught. If K is less than 1, when K is less than 1, if K is less than 1, then what will be log K? It will be minus. If K is less than 1, log K will be negative. If K is greater than 1, log K will be positive. If K is equal to 0, then log K will be 0. Log K, if K is equal to 1, log K will be equal to 0, right? So let us take this condition, first condition let us take. k is less than 1. If k is less than 1, right? So you can also write the equation in a different way. You can also write the equation in a different way where, right, whatever it is, doesn't matter. Log k base 10 will be equal to minus log k. For understanding purpose, I am writing in this way. Log k base 10 will be equal to 0. Okay. So this can also be written as delta G naught is equal to, if you convert the log k, that is log k means here it is base e, then I can write it as minus 2.303 RT log k base 10. Okay. So let us take here, if k is less than 1, log k will be negative. If it is negative, minus 2.303 RT, negative into negative gives you positive. So delta G naught will be positive. Delta G naught will be positive means delta G naught will be greater than 0. Greater than 0. So greater than 0. It is less than 0. So this is not the incorrect. But what is asked? That incorrect is asked. So this will be the correct answer. That will be the correct answer. Why that is correct answer? Because the question asked is incorrect match. Second option let us take. This is all what first option we are speaking about. So second option let us take. What is that? Delta G naught is equal to 0 if k is equal to 0. Log k is equal to 0. Then what you write? Delta G naught is equal to minus 2.303 RT into log k is equal to, if k is equal to 1, log k will be equal to 0. So 0. Then that will be, delta G naught will be equal to 0. Understood? Here is a condition you see. If k is less than 1, delta G will be greater than 0. So that is what the first one is. If k is less than 1 means negative. If it is negative, then automatically delta G is greater than 0. Okay. So this is wrong, this is right. And fourth option, let us see. Delta G naught is equal to minus 2.303 RT. Here k is greater than 1. If k is greater than 1, log k will be positive. So what will you get? A positive value. If you get positive, negative into positive gives you negative. So delta G naught will be negative. If delta G naught is negative, we say that delta G naught is less than 0. It is negative, delta G naught will be less than 0. So delta G naught is less than 0. See, this is correct. So 3 options are correct. 1 option is wrong. And what is asked? What is the wrong option? Wrong representation. So this will be wrong representation. Understood? So we shall meet in the next session with some more questions on Gibbs energy. Thank you.